Okay guys, so we're going to have a look at catalysts today. I'm going to have a practical to look at as usual. So first of all, what are catalysts? How do they affect rate of reaction? So a catalyst is defined as something, a chemical, that increases the rate of reaction without being used up, so there will be the same amount at the end, or without having a permanent chemical change. So this doesn't mean it doesn't change during the reaction, but at the end when you collected it is the same chemical as it started out as. So if you did a reaction, i.e. the mass of catalyst at the start of your reaction, at the end of the reaction will be identical. None of your catalyst will have disappeared. When we say something, you will have encountered a few catalysts before, probably in biology. Enzymes are a form of biological catalyst, and we'll have a little look at enzymes as well. Okay, so if we have the question, how does a catalyst work? The textbook answer as such is a catalyst will offer an alternative route for a reaction that has a lower activation energy. Now we're going to talk a bit more about the lower activation energy alternative route in the next couple of lessons, so don't panic straight away. But this is how we would define how a catalyst works. So think about this alternative route as like going into Singapore city centre on the PIE rather than going in along Bukit Timah Road or using back roads or something like that. The catalyst is offering like a highway, an expressway route to get to the end of the reaction where the cars can move faster, which means they have a lower activation energy. They're not getting held up, they have not go around corners, things like that. So a catalyst is kind of like an expressway over using back roads. So because this alternative route has a lower activation energy, what this means is that our particles in our reaction, more of them will now have the energy above this activation energy because we've made the activation energy lower. So there's going to be more particles that have got higher than that now than there were originally. And so there are more successful collisions. And I hope you're all yelling at me to write per second at the end, because it is more successful collisions per second that matter for our rate of reaction. Okay, so what do we actually mean by the alternative route? Well, because catalysts are reaction specific, so a specific catalyst will work for a specific reaction, you just don't have the thing called catalyst that you can throw in. It kind of depends how this alternative route happens. So there's a couple of different ones that we'll just have a quick look at. You don't need to remember them specifically, it can just be interesting. So some catalysts may hold the reactants in a particular position so that you get more chance of them colliding with the correct orientation, which remember is one of our requirements for our rate of reaction to happen, for our reaction to happen quicker. So they can hold in the correct orientation. Some of them will attach the reactants to the surface, which by attaching to the surface, the bonds actually in the chemical have to weaken so that they can stick to the surface a little bit. And obviously if the bonds are a bit weaker, they're easier to break apart, and that means we need less energy to break them. These two tend to be what we call heterogeneous catalysts, which we tend to mean as a solid reacting it with solutions. So the catalyst would be a solid surface that the solutions can stick to, or a solid and a gas. So they're in different states. So you've got a solid and a gas, solid and a solution. The final one, the most complicated one, is some catalysts will give or take electrons to and from the reactant so that they are more likely to react. So if you remember when we looked at halogens, halides are far less reactive than the halogens. So if you wanted to make fluoride react, you might want a catalyst that takes the electron off of the fluoride and turns it back into fluorine so that it's more reactive. The thing to remember about this is that the electrons return or leave the catalyst again. The catalyst gets the electron back or gives the electron away again at the end, so it's still the same chemical. The catalyst still ends up with the same amount of electrons at the beginning, at the end. And these tend to be what we call the homogeneous catalysts because they're in the same state as the chemicals that you're dealing with. So they're in solution as well, or they're gases as well, so everything is in the same state. One other thing to note with this one, we've talked very briefly about it. This is an example of a redox reaction, giving away or gaining electrons, so they're a type of redox. So today you're going to have a look at the testing catalysts. So we're going to have 4 different types of catalysts that we are going to put in our chemical and make some observations of what they look like, what results we get. So the reaction we are going to use, guys, our example reaction, we're going to take hydrogen peroxide because it decomposes to form water and oxygen very slowly, naturally. We can speed it up using a catalyst. So our equation for our reaction is this. H2O2, this is the hydrogen peroxide, goes to H2O, and O2 goes to water. So pause the video, you should be able to balance the equation. Alright, you should be back with me, and hopefully you have balanced the equation to have 2's in front of each of these. It's important that you remember this equation, guys. It's one of the ones they can ask you for. The other thing to note, our catalyst is not on the equation anywhere. Okay, you do not have to show your catalyst in the chemical equation. If you did want to show it, sometimes people like to say that they did use a catalyst in the reaction, you would write it above the arrow. It doesn't go into the equation because it hasn't changed. It isn't actually part of the reaction overall. So if we were using, for example, the manganese dioxide, you would write the catalyst over the arrow like that just to show that you have used it.